Okay, let's get started. Everybody, could you see my screen?
Yes, sir.
Okay. As you can see, last class we were discussing calculating the G parameters and admittance, that is Y parameters for the two-port networks. So today we will continue that discussion. Mainly we will be solving few numerical problems. So as you can see, the one problem, obtain the Y parameters for the following T circuit. So this means for this circuit, you have to find out Y parameters. So Y parameter means admittance parameters, Y11, Y12, Y21, and Y22. So therefore, first everybody, like if you remember, look this one. We were discussing how to calculate the admittance parameters. So look the top right side figure, figure B. There is current source I1. On the right port, there is current source I2, voltage here V1 and then V2, and then linear network. Here basically those admittance parameters. Now here right side, it is explaining how to calculate the admittance parameter. So this is the generalized equation. I1 is Y1 on V1 plus Y1 to V2, and I2 is Y2 on V1 plus Y2 to V2. Therefore, by using this equation, you have to find out those four parameters. Now, how to calculate Y1 and Y21? Here you see, right side. It is mentioned like Y1 is I1 over V1. I mean, which is derived from this first equation. If you put V to 0, then you can get Y1 is I1 over V1. So that's why you see that left side port, there is current source properly, voltage V1 appears, but right side is shorted. So this means that to calculate Y1 and Y21, you have to make right port short circuit. This means the voltage is 0, you see, V2 0. And that is the reason in that equation we are putting V2 0. And I2 current is entering, and from this side ion current is entering. So similarly, when you will be calculating these two, Y12 and Y22, see here I have written Y12 ion over V2 from the first equation. This means in that case V on 0. So V on 0, see everybody, left side that is short circuited. That's why it is V on 0. So this means the current is properly flowing, which is ion. And right side port, you have the current source I2. Consequently, voltage appears V2 and I2 current entering. So using this concept, one right side port sorted, next time left side port sorted, you have to find out those four parameters, which is called that admittance parameters. So therefore, because everybody, you will be solving this problem, so everybody please note down these two circuits or write down these two equations and see these equations, how to calculate those four parameters. So I think you have these things. Last class, I told you to write down. Uh, so I recommend you all please note down these things, or you can take a picture and then we can start solving. That will help you understand. Everybody, could you follow me?
Yes.
Yes.
Okay. So therefore, see, on then next time you will make practice. Okay. So everybody see. So what we will do at first, I will make right side shorted. Therefore, right side I will make short. So if I make right side short, and then I am assuming at the first port, left side port, there is current ion is flowing. So if I do that, so the see everybody, let me make it bigger. Okay. So everybody look, this was my original circuit. And see here, first I made right side port shorted. This means V2 0. And then I2 current is entering. and left side I am assuming there is a current source ion. Now everybody see Y11 is ion over V1. This means I am taking from here this one. Y11 is ion over V1. Exactly, I wrote that one. So now you have, so you don't need to find out ion, but you have to find out V1 here. So what is V1? Everybody see this circuit. What is V1? V1 is ion, that current going, multiplied by the equivalent impedance here for this portion. That is V1, because V1 is from this point to this point. So you know current is entering. If you can find out what is the impedance here, equivalent impedance, then that impedance multiplied. So now first to do that, so what is the equivalent impedance? This one is shorted. So this means that this is 18 ohm. So everybody see 18 ohm is in parallel with 12 ohm because this is shorted. So this is on common point for both of them and this is on common point. So these two are in parallel. And then that parallel combination is in series with 6 ohm. So that's the right side you see I have done. I am making parallel equation 12 multiplied by 18 over 12 plus 18 which is 30 plus 6 this number. So I got 13.2 ohm. So that I am doing. So Y on is ion over V on. So ion is ion, you don't need to do anything. So for V on you put 13.2 multiplied by ion. So you see ion cancel. So 1 over 13.2 is 0.0757 second, or I expressed in millisecond 75.75 millisiemens. Everybody, do you understand this one?
Yes.
Yeah, okay, great. So now next time you see, also we have to find out Y21 from the same circuit, Y21. So Y21 is I2 over V1. Again, that is coming, from here. Y2 is I2 over V1. So if I do that, so what is I2? Now I have to find out what is I2. So therefore everybody see this circuit. So I2 means actually, the current, total current is entering, it is flowing through 6 ohm. After coming at this point, it is being divided into two parts. Something is going that side, something is coming through 12 ohm. So this means I2 means actually how much current is flowing through 18 ohm. So therefore, if you apply the current divider rule here for ion is the total current and how much is flowing through 18 ohm, and then that will be your I2. Just you need to give a minus sign because it is in this direction, but ion is coming in this direction. So everybody's here I am doing that one, this I2. First I put minus sign because of that opposite sign. And then look the current divider rule, ion is my total current. So I am finding the current through 18. So I have to multiply by 12. So I am doing that. Ion multiplied by 12 divide by 12 plus 18. This two, so which is 30. So I got minus 12 over 30 is minus 0.4 this ion. So I got ion. So in that equation, Y2 on I2 over V1, I put I2 this value in the numerator. Now I2 over V1. So what is V1? Again, the V1 is the same that we used in the previous parameters. So 13.2 ion, I put it. So ion cancel, then minus 30.3 millisiemens, or here Siemens minus 0.0303 Siemens. So there will be minus sign here. I think everybody understand this one as well. Now, you see, next time we will assume that there is current source here. Current is I2, current source, but left side port is shorted. So everybody see this one. Now I am assuming I2 is flowing. There is voltage V2 here, but this is current ion and V1 is 0 because this is shorted. So with that, what I will do, I will be finding out first Y22. Y22 is I2 over V2. This one, I2 over V2. So I2 is I2. You don't need to do anything. What is V2? V2 is from here to here between these 2 points. So I2 multiplied by this equivalent impedance, this whole portion. So again, likewise the previous case, if you see this one, because this point is shorted, so this means 6 ohm is in parallel with 12 ohm, and then 18 ohm is in series. So I am doing, you see right side, 6 multiplied by 12 divided by 12 plus 6 is 18 plus this 18, this one, series on. So I got total 22 ohm. So this means my V2 in this equation, V2 is I2 multiplied by that 22. So I2 cancelled, 1 over 22 is 0.04545, 45.45 millisiemens. So that is done. And then one more parameters, Y12 is ion over V2. Ion over V2. So V2 is that one, just we did 22 I2. What is ion? How much is flowing through ion? So sorry, through that 6 ohm. So, but you have to consider from this side because there is no source here. So I2 is coming, after coming at this point, it is getting divided into two parts. Some portion is going through 6 and some portion is going through 12. So that's why you see here I am doing, but I am finding ion. So ion is in this direction. So I put minus sign. And now I am applying current divider rule here for I2. So total current I2 multiplied by, because I will be finding this one, multiplied by this one, 12, and divide by 6 plus 12, which is 18. So I got minus I2, and this gives me 0.667. So I plugged in this one for ion here, and I know V2 from here. So I2 cancelled. Finally, I was minus 30.3 millisiemens. So then I am done with calculating all four parameters, Y22, Y12, and from here Y11 and this one Y21. Everybody, could you follow me?
Yes.
Mm-hmm.
Okay, great. So if you have understood this thing, then I would recommend you all now make some practice. You all do yourself. So I would recommend you all, everybody, keep this thing handy in front of you in your paper. This is for admittance calculation. Let me squeeze much. This is for admittance calculation, and then the next one for impedance parameters calculation. So if you, I mean, already I uploaded these things in the last class, or you noted down, or if you like, once again you can do. Now everybody please make some practice. You see, this is calculate ion and I2 in the two-port network of the following figure. So here you can see those four parameters are given: G11, G12, G21, G22. Keep in mind this is minus J4, minus J4. And right side, this is already sorted, V2 here and I2. And left side, this voltage source 2 at an angle of 30 degree, and there is a 2 ohm resistance here. And then this point, from this point to this point is V1. This V1 is not here. Keep in mind, V1 is after 2 ohm. And then this current is ion. So current is fine. That is that current. But keep in mind, V1 is not this one. V1 is from this point to this point. So based on that, can you determine ion and I2? So therefore, ultimately, what you have to do, everybody first understand, your G parameters are given. You look, your G parameters are given. So what you have to do, everybody, first you have to write down these equations. Everybody, please write down these two equations. Everybody, please write down these two equations with respect to this circuit for impedance parameter determination. Write down these two equations. And there you all plug in the given values. then easily you can find out what is ion, what is I2. That's the question. So everybody please write down these two equations. Have you all written down these two equations for V1 and V2?
Yes.
Okay. So then now everybody go back to this problem. You write down, you fill up that equation. Then you can find out what is ion and I2. Question is find out ion and I2. That's the question. So everybody just fill up that equation using the given parameters. And then see what value you are getting for ion and I2. So here let me write down. I'm writing down the answers for you. We keep going. Okay, so everybody see, I have written down the answers for you. So ion should be 200 angle 30 degree milliampere, and I2 should be 100 angle 120 degree milliampere. So everybody please try your best. It's a very good practice. So everybody, you will take your third midterm exam again on, I think November 11th. November 11th will be your third exam, midterm exam. And also soon, sometimes this week, you can know your grade for midterm exam too. And November 11th will be the third exam. And then among three third midterm, you can pick up your best two. I will be counting your best two for everybody. So Why I'm mentioning that exam, because you will be looking this type of problem in that exam, midterm exam 3, November 11th, like about 2 weeks away. So everybody start from those two equations that you wrote down. These two equation is your basis, and all those G1 on G1 to G2 on G2 are given, and you put V1 and V2. So everybody you can clearly see what is the value of V2 here. What is the value of V2?
0.
0. Great, because this is short circuited. Excellent. And then what should be the value of the V1?
The voltage source minus 2 I1.
Exactly. Exactly. Right. So everybody see, as I said, V1 is not, this is not the V1. V1 is here. So V1 is voltage source minus current is the same that ion. So ion multiplied by 2. This means this source voltage minus this voltage drop, that is your V1. So therefore, in the equation for V1, you write down that one. And for V2, you put 0. And then you keep going and solve with the help of phasor algebra and simple algebra. You should be getting this result. So everybody please make this practice. I mean, you may leave your result in ampere, that is fine. I just expressed in milliampere. But of course, you can live in ampere, like 0.2 here 0.1 ampere. That will be fine. Is everybody trying? I mean, once you write down, fill up those two equations, V1 and V2, and put V1 is 230 minus 2 ion, and for V2 0. And then in the equation, you will be noticing that you have only ion and I2, those two variables. Now you solve for ion I2, whatever technique you use, algebra, all matrix form, or whatever way you do. And of course, you have to apply the phasor algebra because there is J. Uh, then you should be getting with little effort ion this one and I2 this one. Has anybody got the result so far?
Yes.
Exactly same.
Yes.
Okay, great. Yeah. Um, so everybody see here as calculating. Um, I wrote that equation V on 6 I on minus J for I2. I mean G on 2. I plugged in those values and I am writing that V on value that I said 230 minus 2 ion and V2 0. And then I am substituting V on and V2 into this equation. So from first equations, I got this one and I simplified, you see, 6 and then plus 2 ion, 8 ion and minus J4 and then I put this on right side. And from this equation, after putting V to 0, I got this one. From here, I calculated I2 value from this equation. And then I am substituting I2 value into equation A. And then you see, after calculating, I am getting ion 200 angle this one. And I am substituting ion value here into equation B. So I am getting this. So everybody, do you understand this one?
Yes.
Yes.
Yeah, so you just see and then you say how you are doing. If you have any mistake anywhere, then just see this one. Even you might not need the calculator. So without calculator, you can do this thing, I believe. Okay, then you please practice on more. Uh, this time you calculate the G parameters. Everybody see this circuit. Obtain the G parameters for the following network in this figure. Uh, there is 1 ohm resistance here. I mean, we did similar things with these 3 component, but for example, there is one more component. Then based on this, calculate the G parameters. So G parameters means finding this one, G on, G2 on, G on to G2 to. So therefore, everybody, please note down this one, or you may have already in your note from previous class, or write down these 2 equations, V1 and V2, then you will be able to do. So everybody see this one, again right side you will be making open circuit to calculate the G on and G2 on, and next time you will be getting first port open circuit, and right side there will be voltage to calculate G on 2 and G2. Just you have to apply these 2 technique, this one and this one, then you will be getting. So everybody now try this one, obtaining the G parameters for this circuit. First you apply the voltage source on the left port, keep this one is open. Next time you apply the voltage source right port V2 and then keep this port open. Then what are the parameters? Those 4 parameters. So let me write down the answers for it so you can match. Everybody please try. Okay, here see, I have written down the answers for you. G on should be 4 ohm, G2 on 1 ohm, G on 2 is on ohm as well, and G22 should be 1.67 ohm. This should be the answers. So everybody please try your best and match. So therefore, once again, everybody, you have to apply this technique, this one, to determine impedance parameters. First, to calculate Z on G21, you have to keep right side port open and apply voltage on the left port. Next time to find out G on to G22, you apply voltage on the right port, but make the left port open. And then you can say these equations, G on, G2 on, Z on to, and G22. So everybody please try your best and try to understand, then like you will be done in your upcoming midterm exam plus the homework that I assign similar problem. So you are done. And these will clarify your knowledge in like series parallel combination, equivalent impedance and current divider rule, voltage divider rule, everything is coming here. Is everybody trying? So far, have you got any of the parameters?
Yes, I got them.
Okay, all of those?
Yes.
Oh, great, great. Julian, you got?
Yes.
Okay.
Was unsure about the two middle ones, the Z21 and Z12. For whatever reason, I had them negative, but I had the same value, but I think I should not have put a negative sign.
No, there should not be negative. Can you check again? So you see here, when right side is open, so your I2 is 0, right? I2 current is not flowing. I2 0. So when you're finding the voltage across the 2 ohm, V2, for example, so that V2 is due to the current that is coming from the left side source and flowing through 2 ohm. That current you have to find out. Because I2 is 0. So I2 is not going here or anywhere. I2 is 0. So therefore, I mean, you may write that V2 here is I2 multiplied by 2, but that I2 basically which is coming from left side. So probably I think you gave the I2 direction here, I2, and that's why you put the minus sign, I'm guessing. But you see, because this is open circuit, ultimately your I2 is 0, I2. So therefore, as I said, I mean, the current that is flowing through 2 ohm, that is due to the left side source. So that current you can give the name I2 here, this current, but ultimately that, so you don't need to give any minus sign.
Yeah,
Julian,
that was the problem.
Julian, do you understand?
Yep.
Yeah. So that's why the same thing when you will be considering source on the right side, and you see ion current, for example, this is open. So ion current is 0. Ion current is not flowing because this is open. So therefore, again, if you find out the V on here between these 2 points, but current is not flowing here. So ultimately, V on you have to measure across 6 ohm, but then current is coming, that is the right side source. So therefore, again, you can say V on is ion multiplied by this one, but that ion actually the current which is coming due to the right side source. So here you don't need to put the minus sign again for both of these. Is anybody else got the same result? Alex, so far I think Julian and Brad said, and anybody else?
I think I got it.
Okay, great. Exactly the same values. So therefore, everybody see, everybody look the calculation. Okay, so let not be much more bigger. Everybody see. First, I am assuming there is voltage source on the left side, V1, and ion is flowing, and right side is open. This means my I2 is 0. So now I just wrote these two equations for understanding. You may not need to write those two equations. So G on is V1 over ion, meaning that in that case I2 is 0. So what is my V1? Everybody see? V1 means this current ion multiplied by this equivalent impedance, this one. So right side you have see, I have written V1 is ion multiplied by G, total impedance or equivalent impedance. So which I got ion multiplied by 4. And then here I am showing the calculation of G. So you see, this 4 and 2 are in series, 4, 2. So 4 plus 2 is 6. So that is in parallel with this 6. And that combination is in series with 1. So that's why I have written 6 parallel 4 plus 2. And that result is in series with 1 ohm. So from here I got 4 ohm. So this means my V1 is 4 ion. And then, so I wrote G1 and 4 ion over ion. Ion cancelled. This is 4. So next time, you see, G21 is V2 over ion. What is V2 here? So therefore, because I2 is 0, so V2 is what current is flowing through this one, multiplied by 2. So now you have to apply the current divider rule. You see, current ion is coming. It is entering at this point, and then it is divided into two parts. Something is going here, something is going that path. So you have to find out current flowing through this one. So that's why ion multiplied by this 6 divided by 6 plus 4 plus 2. This means 12. Thing that I am showing here. I2 is ion multiplied by 6 over 12. So just ion over 2. And then V2 is that current. I gave the name I2, but actually this is not, this is already 0. So I2 means the current flowing through this 2 ohm. That is the meaning. So then 2, this one 2 multiplied by that current, ion over 2. So 2 cancelled. V2 is actually ion. So I plugged in here V2 over ion. So ion cancel. This is just 1 ohm. So next time you come back this one, that I am applying voltage source on right port. Current I2 is flowing, but left port is open. And then this means current ion is 0. So here you are getting G22 V2 over I2. That is the first thing. So what is your V2? V2 is I2 multiplied by G. So what is G? The equivalent impedance of this one. So but the current is not flowing here. So what is happening? You see 10 parallel, G is 10 parallel 2. This means these two are in series and then parallel with 2. So that's a 10 parallel 2. So I'm getting 1.67 G value. So this means my V2 is I2 multiplied by that number, 1.67. Then plug in this one, V2. I2 cancelled, I got 1.67 ohm. So next, the G on 2. So G on 2 is V1 over I2. Now, what you will be getting? V1 over I2. So what is V1? V1 is here. So, but current is not flowing here. So ultimately, V1 means voltage drop across this 6 ohm. So then you have to find out how much current is flowing through 6 ohm. So you see, I am doing it here. I6. This means this is, then apply the current divider rule. Total current is entering at this point, I2, and then something is go through 2, or remaining is going through here. So you have to find out that current. So that's why I2 multiplied by 2 divided by 6 plus 4, 10 plus 2, which is 12. See the current divider rule. So I got I2 over 6. So this means now my V1, which is across this one, because ion is 0. So 6 multiplied by that I6. So I got ultimately I2. So therefore I am done. my V1 is I2 and this is I2. So I2, I2 cancel, just 1 ohm. So my G12 is 1 ohm. Everybody, do you understand?
Yes.
Yes, sir.
So, Julian, is this fine?
That's excellent.
Yeah.
That's
Okay.
fantastic.
Yeah. The probably now I right. So I am guessing that by looking this sign, opposite sign, probably you put the minus sign, right?
Yeah, it's just
Yeah.
probably just quick overlook.
Yeah. So therefore, you see here. I mean, although I didn't know to talk, but here I am writing like I6. Because I mean, even though you can give the name, for example, this one is ion, but it's still because ion is well, like 0 because this is open circuit. So whatever current is flowing through 6 ohm, this is due to actually I2. That is the thing. Okay, so therefore I guess everybody understood. So with that, I think we like to conclude this chapter. In next class, I will study application of Fourier series and Fourier transform technique to circuit problems. So I hope you all already covered that Fourier series technique both in math and signals and system class. But in this class, we will be applying to solve some circuit problems, the Fourier series technique. And then we will be like going over about 2 to 3 classes. Then we will almost done. We will start the last chapter, which is 3-phase circuit. Then we will be done the whole syllabus. Okay, so does anybody have any questions, comment? So